Welcome to another episode of Introduction to Security offered at Tufts University. I'm Ming Chow, I'm Associate Teaching Professor. We're still in October, and now you're starting to see a lot of interesting things happen. And perhaps today may shed some light on what's been going on in recent events, and also, how a lot of why your data gets lost all the time. Today, the focus is going to be on web security. So, web security still accounts for a significant percentage of incidents, security incidents that happen on a day to day basis. We're going to cover the biggest fish in the fries today: cross-site scripting, SQL injection. We're also going to be using a nice playground that hopefully you can follow along as well too, a real target that you can actually use and hone your skills. The damn vulnerable web application. And then we're also going to cover one bit of topic that you'll find very, very useful for the long run, and that is going to be using Burp Suite. Okay, so let's go to my desktop. Okay, so before we begin, one of the things that I want to give some preliminary information, preliminary details on how the web works. So how the web works in simple details is question and answer. Q&A. Think of Siri. Think of Spotify when you ask for a song. You ask for a song, hey, you have the song XYZ, and then Spotify will say, yeah, sure, I have the song, here you go. Or sometimes we may actually say, no, I don't have the song, sorry, come back later. Okay, but more formally, how the web works is by way of something called HTTP, the Hypertext Transfer Protocol. And how the web works is a request response. It's a request response. One of the things that I like to do, I'm going to open up Firefox. And this is important to know, this diagram. I'm going to go to comp116.org, which is my course website. And in the slides for web security, there is this picture that I really, really like and use all the time. Like, how does the web work? Here you are, here's your web browser, you type in http:// and then whatever it is, like google.com, you hit the enter key, it makes a request to a web server somewhere. Let's, for example, if you type in http:// google.com, it'll send an HTTP request to the Google servers. The servers will do a whole bunch of things, crunch, sends you back a response, which will be like a hello world, or in this case, in the case of Google, having like a nice little search box. This is how HTTP works without the S. This is also how HTTPS works with the S, HTTP secure. The biggest difference between HTTP and HTTPS is that the traffic is encrypted with HTTPS. On a much lower level, in the previous broadcast, one of the things I hammer students on is the TCP handshake. The TCP three-way handshake goes sync, ACK, ACK. And you may be wondering, like, how in the world does this tie in with HTTP? Well, HTTP is layer 7 in the OSI model. And the TCP three-way handshake uses, it's on layer 4, how TCP works. And so what happens is, before the request and response happens, it goes sync, ACK, and once a connection has been made between the client and the server, which is your computer with the browser and the web server, once that connection is made, then it goes request response. Do you need to know this picture for later on today? And the answer is yes. I'll bring this back up again. So right now in this picture, you can see that your client or your web browser makes a direct request to whatever the web server is. So is your browser making a direct request to a server somewhere on the internet? Okay? So that's how the web works. So, okay, let's talk about vulnerabilities. Vulnerabilities on the web, like with web applications, like what are the two biggest fish in the fry? Well, this is where I want to introduce you to the OWASP Top 10. OWASP is, well, before I show this, OWASP is the Open Web Application Security Project. It's a nonprofit foundation. Has many, many chapters worldwide. Boston, where we are right now, where there's monthly meetings, and their goal is to improve the security of software. So it's a nonprofit worldwide organization, nonprofit foundation as well, but their most famous project is a top 10 list. The OWASP Top 10, which is a standard awareness document, as you can see, for developers and web application security. It represents a broad consensus about what the most critical security risks are to web applications. And this is the latest list from 2017. There's been a number of changes, I think like every 3 years, is it? And so here's your list of the top 10 web application security risks. Number one is injection. Number one is injection, such as SQL, NoSQL, operating system, LDAP injection occur when untrusted data is sent to an interpreter as part of a command or query. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing data without proper authorization. So I learned security. I got into security in 2004, thanks to Gary McGraw. And when I was learning, security, namely web security, the number one and number two biggest fish in the fry, two biggest vulnerabilities at that time in 2004 was SQL injection and cross-site scripting. Here we are in the year 2020, and what's still on the list and still number one is SQL injection, and cross-site scripting is still on this list at number 7. XSS flaws occur when an application includes untrusted data in new web page without proper validation or escaping, or updates an existing web page with user supplied data using a browser's API that can create HTML or JavaScript. XSS cross-site scripting allow attackers to execute scripts in the victim browser, which can hijack user session, deface websites, or redirect the user to malicious sites. There's also a number of other, the other 8 issues include broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfiguration, insecurity serialization, using components with known vulnerabilities, like for example, if you're developing apps using Node.js, NPM is Node packages, and NPM packages are always riddled with vulnerabilities. Insufficient logging and monitoring. Do you need to know each and every one of these 10 in order by name? No. I mean, you do need to know the big ones, like injection is number 1, cross-site scripting is at number 7. But you also want to get the most important thing is you want to understand the gist of what the top 10 list is. It's a guiding document that shows you some of the most critical security risks. It's not perfect, but but if you're a developer and you're not familiar with anything about security or web security, this is a good guiding document. And I can't tell you how many people I've heard that they work with senior engineers and they've never heard of cross-site scripting or SQL injection. It's still a problem up to this day in 2020. All right, wait a minute. We can talk about these risks, but how do you find them? How do you find injection vulnerabilities? How do you find cross-site scripting? Are there legal playground where you can hone your skills? And the answer to that is yes. There's a couple of ways. The two biggest ways that you can hone your skills and look for web application security risk legally. First is using bug bounties. lots of companies, Facebook, Apple, HubSpot, GitHub, they all have bug bounty programs where they lay out the rules on, well, we work with security researchers, we, to find vulnerabilities, we fix them, and we also reward them as well too. And a lot of these companies have bug bounty programs. The rules are all spelled out. What we're going to do today is we're going to actually use a deliberately vulnerable web application and learn more about injection flaws and cross-site scripting. And ultimately, we'll actually end today with using Burp Suite. Okay? So, wait a minute. Are there deliberately vulnerable, you may be asking yourself, there are deliberately vulnerable applications that I can use and download? And the answer is yeah, you can. GitHub has many deliberately vulnerable web applications. One of my absolute favorites is the damn vulnerable web application, the DVWA. It's www.dvwa.co.uk. The damn vulnerable web application is a PHP and MySQL web application that is, well, damn vulnerable. Its main goals are to be an aid for security developers to test their skills and tools in a legal environment, help web developers better understand the processes of securing web applications, and aid teachers and students to teach/learn web application security in a classroom environment. So here's the main website. The source code is all on GitHub at github.com/digininja/dvwa. And that's just all the source. Give you the instruction for database setup. So you can create like a web server on either a virtual machine, either on your local machine by way of like VMware or VirtualBox, or you can actually create a virtual machine instance on, let's say, AWS or GCP, and you can install this as well. But you don't ever want to make a deliberately vulnerable web application exposed and publicly available. Well, but for today's instance, okay, here it is. It says, here's a warning, and the source code is like, the damn vulnerable web application is, well, damn vulnerable. Don't upload it to your hosting provider's public HTML folder, internet-facing servers, as they will be compromised, and they will. It is recommended that you use a virtual machine, such as VirtualBox, VMware, which is set to network address translation mode. Inside a guest machine, you can download yada yada yada. So I'm actually going to break that rule. And yes, I know that we're live on Twitch and on YouTube. So, but if you want to open this up for students and other people, people who really care about learning, I think today I'm going to bite the bullet. I'm actually going to host it on I have an instance running on GC on Google Cloud, and the IP address is 35.196.150.0. Yeah, so I just ask people, do not DDoS this thing. That is not cool. So if I go to the site, what's up with that? I got a nice little FBI warning here. That used to be an April Fool's joke. I forgot where I got that from. But if you go to the URL bar, and now you add /DVWA after the IP, which is 35.196.150.0, and then you just add a /DVWA on there, you'll get the damn vulnerable web application running. And for those of you who are watching right now, you can feel free to follow along, but don't DDoS the site, please. Thank you. Don't ruin the fun for everyone. So the username is admin. The password is PASSWORD, password. And here we are. Here is the damn vulnerable web application running on this it's on the internet at 35.196.150.0. So as of right now, of course I gave you that warning message again. This application is vulnerable. So on the left, you see Home, Instructions, Setup, and Reset DB. I can always use this option There's also a lot of exercises in the damn vulnerable web application that you can use, including brute force, command injection, cross-site request forgery, file inclusion, file upload, insecure capture, SQL injection blind, weak session IDs, XSS, yada yada yada, SSS, and a JavaScript exercise. These are all exercises. Let's start off with the command injection. As you saw this on the OWASP Top 10, this is number 1. Okay, injection is number 1 on the OWASP Top 10, but this one has a vulnerability. This little page, this little exercise, there is a vulnerability with that, with this. And the form just says ping a device, enter an IP address, and hit submit. What could possibly go wrong? Well, let's enter an IP address. I can also enter 127.0.0.1. I hit submit. And there you go. I got some response. Well, the problem is, and this is really the gist of most, if not all, web security issues, is there's something wrong with this. And what's wrong with this is, if you actually take a look at the view source button, which is right here, which I'm where my mouse is, and you do a view source, you have PHP code. So what it does is it gets the input. You don't need to know PHP, the programming language, but you can read the comments as how the page works. It gets the input, determine the operating system, and execute the ping command. And then the feedback is sent for the end user, which is this. The problem is that there is nowhere, after you type in an IP address in the form, there's no input validation. What happens is, if you actually just, what the code does is just takes whatever you type in and just execute it as is, takes it for granted. It just takes your, whatever you type in, your IP address, and it just feed it to the ping command depending on your operating system. But there's no input validation. But if you actually remember, if you actually have worked with the shell before, if you work with the command line, you can use a semicolon and you can execute multiple commands. So if I do 127.0.0.1 again, but I put a space and then a semicolon and then a space, and then I put in another command, something like cat, I want to cat out the content of /etc/passwd, the password file. Watch what's going to happen. Here you go. The problem is now not only going to give you the result of ping based on the 127.0.0.1 IP address, but it also will execute the follow-up command after the semicolon, which is print out everything that's in /etc/passwd. And there you go. I can do this again. 127.0.0.1 space, you don't need a space, but you can do semicolon, and then you do ls minus la slash, ls space minus la space, and then the root folder, and it will just show you all the contents in the root folder directory. Okay? If I do 127.0.0.1, what happens if I do curl? I can do curl google.com, or https google.com, and watch what happens. You're going to get some interesting results to say, wow, I even got a link here to click on the document has moved. So this is what happens when a web application or a page or a function doesn't sanitize user input. It just takes it as it is. It just takes it as it is. No security. You just blindly trust whatever the user types in, and the user can get away with a lot. So the defense against this would be, okay, check if the user and if whatever I typed in is really an IP address. Just extract the IP address, which is 127.0.0.1, and just drop everything else. That's one way. That's one way to defend against command injection. The other one, of course, is going to be like, don't allow any command with semicolon, non-numeric, like numbers and letters. They can, like letters, forget about those. The best way is, check the user input and just take out the IP address, then feed it into the ping. Just feed it into ping. That's the way. That's the best way to to resolve the command injection issue in this case. Okay, so that's the command injection vulnerability exercise in a damn vulnerable web application. Let's move on. Let's move on to SQL injection. So what is SQL injection? In plain English, what SQL injection is, in plain language, SQL injection gives you access to data that you shouldn't have. I repeat, SQL injection gives you data that you shouldn't have access to. One of my favorite articles was written on Vice a few years ago. It's called A History of SQL Injection, the hack that will never go away. One of my favorite articles. And it gives you a history of, well, SQL injection, the hack that will never go away. It was been around. SQL injection has been around for for 15 years. It's still the #1 threat to websites. And it's also, don't be surprised if this is the way that, your data got leaked out. Pretty timely. That also includes election data as well, too. Okay? SQL injection was first documented by Rainforest Puppy, also known as Jeff Forstall. There it is. And here's the document. Like, structured query language is a programming language used to manage databases. In essence, it is used when a website needs to call up a piece of information from its database, either to process it or to present it to a user. But Forstall has found that typing certain characters would force a server to reveal information stored on it. People can possibly piggyback SQL commands, he wrote. Alright, and here he is. Here we go. For over 15 years later, for disclosed, SQL injection repeatedly sits at the #1 spot of vulnerabilities in the OWASP Top 10 report, which I just showed you, which is released every 3 years by OWASP, a nonprofit that monitors threats that websites face. SQL injection is always a #1 risk. That is a reflection of just how many incidents that are out there, as well as other factors that keep it very high up there. Troy Hunt. Hello, Troy. I'm going to give you a shout out for Have I Been Owned in a motherboard interview. When you go to a web page and you make a request, that parses part of the data in the request back to the server unsaid. For example, you read a news article, and in the news article, in the address bar, it has ID equals 1, and that gives you news article #1, and then you get another one with ID 2. But with SQL injection attack, the attacker changes that ID in the address bar to for something that forces the database to do something that it's not meant to do, such as returning a piece of private data. Again, what I just said, the whole point of SQL injection is to give you data that you shouldn't have access to. Okay? There is an automated tool that you can use, one of my absolute favorite, called SQL Map, that can automate the whole process, everything for you. Okay? This is a really good article. I see the FBI has joined the chat. Hello. Hello. I have a lot of students that actually do want to work for the FBI. That's good. Let's do a SQL injection exercise. Let's go to SQL injection. Okay. Do a user ID. 1. Okay, what happened if I did 2? Okay. What about I 3? Not bad. But here's the challenge. The challenge is there a way that I can just return all the records in the database and spit it out to the screen? Is there a way I can do that? Well, let's actually go to View Help first. Let's see what they got. Let me just blow up the text. A SQL injection attack consists of inserting or injection of a SQL query by way of the input data from the client to the application. A successful SQL injection exploit can read sensitive data from the database, modify database, insert, update, execute administration operations on the database, such as even shut down the database, recover the contents of a database system, yada yada yada. In which SQL command, okay, SQL injection attack are a type of injection attack in which SQL commands are injected into data stack plain input in order to effect the execution of predefined SQL commands. This attack is also known as SQLi. Okay, interesting. But I also now want to see the source. Here's the problem. The real culprit is here. I see the query. Select first name, last name from users where user ID equals single quote $ID single quote semicolon, where $ID is the user input. As you can see, $ID is the variable that holds the user input. I want to copy this line. And I'm going to open up a text editor. I'm going to blow this up. So here is how SQL injection works. ID equals, so I'm going to make a comment, user input. So here is the SQL command. Select first name, last name from users where user underscore ID equals single quote $ID single quote semicolon. Okay, so let's do a few exercises. What if $ID, the variable $ID equals 1? Okay, so now what you do is, in the SQL query, you just replace $ID to be, well, 1. So you have select first name, last name from users where user underscore ID equals 1. And all inside the single quote. Does that make sense grammatically? Yeah, it makes sense grammatically. So you're looking for the first name and the last name. You're looking for a person in the user's database table where the user ID is 1. And if that user is found, return the first and last name. That's what line number 5, that SQL query means. Okay, that makes sense. What happens if the ID is 1337? Okay, if $ID, the variable is 1337, we do the same thing. We just replace what was $ID here to be 1337. And this time it's, bring back the user record where the user ID is 1337. That makes sense. Grammatically, line number 5, the SQL query makes sense. What happens if the ID is something like Shaquille O'Neal? Okay. Now I'm going to copy Shaquille O'Neal. I'm going to plug in chug and replace that 1337 with Shaquille O'Neal. Select first name, first underscore name, last underscore name from users where user underscore ID equals Shaquille O'Neal. Does this make any grammatical sense? The answer is no, and here's why. User underscore ID equals in single quote Shaquille, and in single quote, okay, so you have a string here, but then you have a Neil and then a single quote here. This doesn't make sense. You have an unmatching number of, an odd number of single quotes. It doesn't make sense grammatically. Okay? What if we did this? Instead of Shaquille O'Neal, we do something like A, whatever you want, single quote, or single quote, 1, single quote, equals single quote, 1. That's it. So the user input is going to be whatever it is. In this case, I'll just say A. You can even say AA, who cares? AA, single quote, space, or space, single quote, 1, single quote, equals 1, equals single quote, 1, semicolon. Well, the semicolon doesn't count. This thing right here. The thing that gets highlighted is my user input. what if I plug and chug this in place of Shaquille O'Neal? Now we have a very, very, very interesting query. Select first name, comma, last name from users where user ID equals the string AA, or 1 equals 1, where one and both ones are inside single quotes. Now, grammatically speaking, this makes sense. The number of quotes makes sense. But you also notice, that's what I'm going to get at. What does the 1 equals 1 mean? Well, what does 1 equals 1? 1 equals 1 is always going to be, what does that equate to? This piece right here. I mean, last time I checked, the equal operator, there is an equal operator in the structured query language. But even in real life, you know that 1 equals 1. Last time I checked, 1 equals 1. So this will always evaluate to true. 1 is always going to be equal to 1. Yes, there is an equal operator in the structured query language, so this is always going to be this piece, the 1 equals 1, is always going to evaluate to true. So hopefully that answers your question. 1 is always equal to 1. But you also have an OR operator here. OR. So it's something or true. But the thing is, it doesn't matter what the user ID is. If you take a look at the structured query language, the equal sign is always going to be either, something, equal means equality. Let's take a look at the document. It is. SQL equality, comparison operators. We'll just take this one. Comparison operators. Equal. Comparison operators are used in where clause to determine which records to select. Here's a list of comparison operators that you can use in SQL. Equal equals equal. Not equal is the clashing greater than and less than and greater than sign. You can also use exclamation point equal to. Interesting. So here's an example. If you can use the equal operator to test for equality in a query, which are always going to return true or false. I'm going to close this back out, come back to the screen. But what is anything or true in Boolean logic? What is anything or true? It's always going to evaluate to true. False or true is going to be true. True or true is certainly going to be true. So this statement, number 5, will always be true. And so it's going to return, how you read this entire statement will be select first name, last name from users where true. In other words, bring back every first name and last name in the database table users. I'm going to copy this user input. I'm going to go to the SQL injection vulnerability on damn vulnerable web application. Now instead of typing in a number, because we had to access the source code, so we know how this thing works under the hood, where user ID equals a, whatever it is, AA, single quote, space, or space, single quote, 1, single quote, equal, single quote, 1, hit enter, watch what happens, boom. Now I actually mangled the SQL query to bring back all the first names and last names in the database. Wait a minute, is it surname or is it last name? Oh, okay. Oh, same thing, just labeled differently. So here we go, now SQL injection. Because we can actually mangle, because we know what the source was, and the culprit really is because of the single quote. So the single quote in this case in that query as part of the entire query. So how do you defend against SQL injection? Again, it's all based on user input validation. One way is, of course, the most draconian, which doesn't make any sense, is to strip out all special characters. Strip out special characters in the user input. A more logical, better option is to use, and this is most languages have, is called prepared statements. I'll just do another tab. There's a good Stack Overflow on this thing. Single quote SQL injection. Okay, here it is. Why do testers often use a single quote to test SQL injection? Okay, here it is. The single quote, the character single quote is used because this is the character limiter in SQL. With single quote, you delimit strings, and therefore you can test whether the strings are properly escaped in the targeted application or not. If they are not escaped directly, you can end any string supplied to the application and add other SQL code after it. That's exactly what we just did. The character semicolon is used to terminate SQL commands. So if you send the semicolon to an application and it's not escaped outside the string, see above, then you can terminate any SQL statement and create a new one, which leaves a security breach. That gives you an explanation. Okay, so the best way to defend against SQL injection, of course, is input validation, but there's also another one, which is don't treat the single quote as part of the query. And this is called prepared statements. Prepared statements. This is one of my favorite Stack Overflow posts, which is how can prepared statement protect from SQL injection attacks. So what are prepared statements? I'll come back to this in a few. So remember here, we had $ID. So I can draft this out. If this was using something called prepared statements, it would have something called parameters. Called parameter binding. So there, in this case, you can see there's no single quote being used. And the question mark is going to be bound to some variable somewhere. So the biggest change is that in the future, the single quote will not be part of the operation. It's just going to replace whatever variable, and usually in a lot of like packages like MySQL, like you can do something, I forget what it is. In PHP, you have the query, and then you do something like $variable1. And so what it will take, it takes all the content in variable1 and $variable1 into the question mark. You can also do, if there's like multiple parameters, you can do and last name equals. So it's not just a direct, it feels like plug and chug again, but there's no single quotes involved. A single quote is not part of the query. Variable2. Okay, so what happens is the contents of variable1 gets put into the first question mark, the contents of variable2 gets put into the second question mark. Let's go to that Stack Overflow post. The idea is very simple. The query and data are sent to the database server separately. That's all. The root of the SQL injection is the root of the SQL injection problem is the mixing of the code and the data. In fact, our SQL query is a legitimate program. Okay, we'll expect the data will produce yada yada yada, will produce, this code will produce a malicious sequence. Aha! It works because we are adding data directly to the program body and it becomes a part of the program, so the data may alter the program. Depending on the data path, we will either have a regular output of a user's table deleted. While in the case of prepared statements, we don't alter our program. It remains intact. That's the point. We are sending a program to the server first. Here's how they do it in, that definitely looks like PHP. Okay? Select star from users where ID equals question mark, where the data is substituted by some variable called a parameter or a placeholder. Note that the exact same query is sent to the server without any data in it. And then we're sending the data with the second request essentially separated from the query itself. Aha. So it can't alter our program and do any harm. Okay, so now the latest version of PHP, if you're using PHP and MySQL, PHP with MySQL, by default you now have to use prepared statements. A prepared statement can only protect against data literals, but cannot be used with any part of the query itself. Okay, yada yada yada. Can't repeat myself. So again, SQL injection, still the dirtiest trick in the book, still the oldest trick in the book. Get you access to data that you shouldn't have access to. Okay. So now that SQL injection, let's try something else. Let's move on to cross-site scripting. Cross-site scripting DOM. Document object-based cross-site scripting. Okay, this looks simple enough. Select the language. French. Okay. Spanish. Interesting. Sounds good. But what's the problem here? The problem becomes this. Take a look at the URL. Any option that I pick, the URL is going to change. In fact, our option that we chose is in the URL here. If I choose German, default equals German. Yeah, I know we did all of this, except for one thing. So now I can change, instead of default, I just say Pig Latin. Interesting. What happened if I say leak code? There you go. But what if I did this? Instead of something nice and tame, I do script alert hacked by and then we have a script. I'm going to copy this payload. Boom. So now, instead of some legit data, you have a script that gets executed on the client side. Why is this happening? Go to View Help. Cross-site scripting attacks are a type of injection problem in which malicious scripts are injected into otherwise benign and trusted website. Cross-site scripting attacks occur when an attacker uses an application to send malicious code, generally in the form of browser-side scripts, to a different end user. Flaws that allow these attacks to succeed are quite widespread and occur anywhere in a web application using input from a user, using input from a user in the output without validating or encoding it. Okay, so why is this happening? Again, like, there's no protection. So in this case, why this is happening is because, all your parameters, well, there's a couple of problems. One, all your entries and data parameters are in the URL, so you can just modify it as is. Two, there's no input, there's no validation of what the value of default is. So to resolve cross-site scripting, it's the same idea as how you resolve SQL injection issues or any injection issue. Validate the input. Let's go to the reflected. No, let's go to the stored. This is the one that I really want to pay attention to. Alert FBI here. Okay, I'm glad that people are following along. Now this is the perfect example why cross-site scripting is so deadly. Okay, because if you're on a message board, like a public message board, and someone types in a message, okay, and someone types in a message with a script in it, and that gets sent to every user. So if I hit the refresh button again, alert the FBI was here. Because this stored cross-site scripting vulnerability, anyone in this message board, someone typed a message with a script in here, it gets broadcasted to everyone trying to read this message board. So how does this work? I'm going to type in just mumble. Whoa, wait a minute. Whoa. Just mumble. I can't type in crust. Interesting. I can't go more than a certain number of characters. Looks like I only have 10 characters here. What? Okay, I'll just do just mumble from now on. But what happens if I type hi? I'm going to sign the guest book and see what happens. Yeah, of course, once I hit submit, I also get just mumble hi. I want to do just mumble. There's a character limit here. Now I'm just going to paste this script in. Wait a minute. What? There's a limit to the script too? Wait a minute. I don't believe that. Whoa, interesting. I can't type in the closing script tag, the greater than sign. I can't do it. I bet the input have a max length attribute. Is that correct? That is correct. So the name has a max length of 10, and the message has a max length of 50, if you take a look at the source code. Okay, so here's your deal. How do you actually bypass, okay, is there a way around the max length problem? The answer is yes. Okay, I want to type in a nice script. The one payload I want to have is this. Window.location equals https://4chan.org. But I can't close the script tag, so there's a character limit somewhere. So is there a way on this page that I can bypass the entire character limit for not only the name but the message too? And the answer is yes. And this is the part I want to focus on for the remainder of the session, and this is an important tool to use, is you can bypass any client-side validation that you want. You can bypass any client-side validation. Also, that also includes modifying cookie values, modifying hidden form fields, and I want to introduce you to something called web proxy. I want to reset the database just for because I want to have a clean slate. Now again, don't mess with the system. I'm going to come back to the cross-site scripting stored exercise in a few minutes. Remember that picture I showed you earlier? Which is this. You go to web security, comp116.org, and here's how the web works. Now imagine that in this example that we've been working on is http://35.196.150.0. You type that in, it makes a request to the web server at, well, that IP address that I just said, send you back a response. That's what we've been doing the whole time. What if, but here's the thing, it has been always your browser making a direct request, or your computer making a direct, your browser, your client making a direct request to the web server. That is, your client going directly to the server. What if we did this? What if instead of the browser making a direct request to a server, it makes a direct request, it makes a request to a middleman or a proxy. And then the proxy makes the request to the server. So imagine if there was something in the middle here, where instead of your request going directly to a server, your request goes directly to a proxy. You can do whatever you want in that proxy, and then the proxy sends a request to you. And then of course the web server sends you back the response. What about that? And a web proxy is a very, 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 very crucial and valuable tool for anyone who's doing web application security. Okay, proxies has been used many years. Back in the early 2000s, when a lot of like e-commerce vendors were, storing price in hidden form fields, people were using proxies and mangling the price of like things like really expensive goods like flat screen TVs. So instead of spending like $2,000 on a flat screen TV, you can just spend like 57 cents on one, thanks to using a proxy. And so now I'm going to introduce you to how to use what proxy to use and how do you use one. And a very, very popular proxy that is used in security is called Burp Suite by Portswigger. Burp Suite is actually a suite. If you go for the professional or the enterprise version, which you have to pay for it, it also includes a scanning tool, like an automated scanning tool. So it will scan websites and web applications for things like SQL injection, cross-site scripting, and a whole bunch of other vulnerabilities, web vulnerabilities. Yeah, as you can see, it's a web vulnerability scanner. What we're going to use is the community version. The community version actually is very limited, but it does come with what is called a proxy. Okay? And it's also important to point out here that I'm also using Firefox as my web browser for a very good reason. So you go to the https:// portswigger.net. They also have their own training academy, which is nice, which is free. Highly recommended. Their Burp Suite. And you can go get the community version. And it's public and is available for it's platform independent. It's written in Java, so you can download a Windows, Mac, or Linux version of it. Okay? So let's download the Burp Suite Community Edition. I already have it installed on my machine. I have it all. One of my, like with Nmap, is one of my critical tools that I have. I'm going to fire up Burp Suite Community Edition. Oh, thank you. Thanks for the heads up. Appreciate it. So we'll not go there. We'll go to somewhere else. Like, we can go to like Reddit. Thank you for that heads up. Appreciate it. Welcome to Burp Suite Community Edition. Use the option below. I didn't know that. Thank you. Use the option below to create a project. Okay, whatever. I'll do some temporary project. Hit next. Select the configuration. Well, let's just next. Start Burp. All right. Thank you for that note. So here we go. This is Burp Suite. This is the community version of Burp Suite. It looks overwhelming. Okay, what we got here? We have target. Ooh, we have proxy. Ooh, we have an intruder. We have repeater, sequencer. Today we're going to focus on the proxy. Interceptors on. Now, the newest version of Burp Suite actually have an integrated web browser, so there's no need to configure your proxy settings manually. We're not going to do that today, because we're going to go through the hard way and the original way of doing things. And so you can have a better understanding of how things work, namely, like, how proxies really work and why is it so important. Okay, here's a dashboard, nothing's running. You can see the Pro version actually has lots and lots of more features, such as automated scanning for web application vulnerabilities. But we're actually going to go and use the proxy today. Here we are on the proxy tab. So what is this? Like, how does this all work? Okay, when you open up Burp Suite, anytime you open up Burp Suite, Community Edition, Pro version, doesn't matter. It runs a server on your computer at port 8080, as you can see here. The event log. Source of proxy. Proxy service started at 127.0.0.1:8080. Again, anytime you open up Burp Suite, it will actually it will run a server, a proxy service at localhost, or 127.0.0.1 at port 8080. Why is that important? What you want to do on your web browser or on a system level is make a change to either your network setting or your web browser setting. I like the web browser setting, it's much more simpler, so it doesn't affect my whole machine, where all web requests will now go to the proxy and not directly to the server. Because anything that we've been doing right now at 35.196.150.0, like anything that we do, any operation that we do, like if I click on a button or I click on an exercise, it makes a direct request to 35.196.150.0. But anything that I do on Firefox, what I want to make a change now is this. I want to make a change to my configuration of Firefox, where all requests go directly to the proxy that is running on Burp Suite. So how I do that in Firefox is this. Go to Firefox, go to Preferences. On the General tab, on the General, at the very bottom, on the Network Settings, I'm going to scroll up. I'm going to scroll up. Configure how Firefox connects to the internet. I want to go to the settings of that. I do want to actually configure how Firefox connects to the internet. I want to go to my settings. And this is what I get. Currently, there is no proxy. No proxy at all. No middleman access to the internet. You have an option to also use either your system proxy or even do a manual proxy configuration. I want to do a manual proxy configuration. I want to specify, here is where I specify from HTTP, HTTPS, and FTP. I actually, to click it off, also use this proxy for. I want to now make a direct connection to Burp, the proxy that's running on Burp Suite, which is 127.0.0.1. So I would enter in 127.0.0.1, port 8080. And I also do want to use this proxy for FTP and HTTPS. Socks host, sure, why not? Make sure that manual proxy configuration is now set in Firefox. Firefox is one of those browsers where you can actually, configure how the actual browser, connects to the internet. Other browsers like Brave, Chrome, you have to use the actual system setting on your, whatever you're on your operating system. You have to do the similar steps but at the operating system level, like your system config, like your system preferences, network. I'm going to hit OK. So now any request in Firefox will go directly to the proxy. I'm going to close this window, and now I am actually going to click. Now I'm going to actually move the browser bar up a little bit so you can all see, but I am going to click on XSS stored. I clicked on XSS stored, I just clicked on it. But you notice something is happening. It hangs. Notice that it's waiting on something on the web browser bar, and it's just hanging, well, at the status bar. This is where you have to go to Burp Suite now. And you notice something gets interesting. You notice that the proxy tab on Burp is now highlighted in orange. Click on that tab. Now let's click on the proxy tab and let's see what's going on. Nice. Now Burp intercepted the request when I clicked on XSS stored. You can see all the HTTP request headers. I have a choice to either drop or forward the request. I see this is for XSS_S. I want to forward this. I'm going to forward this and see what happens when I forward. Once I hit the forward button, I'm going to forward this request. Nice. It works. I can also choose intercept off, so it doesn't actually, for everything that I do, gets intercepted. I need this back in a little bit. This time, I got the entire screen. I got the message board again. But this time I'm going to type A and B. A is a name, B is a message. I'm going to hit the sign guest book now. This is a little distracting, sorry. I'm going to sign guest book now. Ooh, you notice that? Burp picked by Proxy and Burp picked it up. Now I see all. All the data, the HTTP request data. HTTP post request at the host. I even have cookie information I can modify. Now, TXT name equals A, MX message equals B, and then of course assign guest book. I'm going to drop this request because I want to make this a little more clear. Ooh, the request was dropped by the user. I'm going to go back. This time I want to have all these A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Okay. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I'm going to hit sign guest book now. Watch what happens now. J, K, nope. I hit sign guest book. Burp picks it up. So Burp Suite picked it up. Here are all the parameters. This is exactly what I typed in for text name. A, B, C, D, E, F, G, H, I, J. Okay. Now, what you can do is you can actually modify the input that I just typed in. So in this time, I can just say, who was that guy that was talking to me earlier? Who was that other person? Was it Lock Muffin? No, just Mumble Crust. Was it just Mumble Crust? Just Mumble Crust. And I'm going to have a message now. So I'm going to have script alerts. I'm going to go way over 50 characters. Hacked by just mumble crust. Okay, so now using the proxy, I can change the input name to be anything that I want, greater than 10 characters, and the message, okay, the message can be way over 50 characters as well. Now even with a screw closing tag, I hit the forward the request. Watch what happens. Boom. There you go. So here is an example of where you actually see how you can actually bypass the character limit of the name and also of the message as well too. Okay, so I'll just do another one. Okay, I'm going to type A. I'm going to hit the sign guest book. Okay, I'm going to type hello lock muffin 99. Finish him. Okay, and the message I'm going to do is script window.location equals https://www.cs.tufts.edu. Let's make it clean. Let's not get ourselves banned. So I'm gonna make the payload of the message to be window.location equals, well, a certain website. So now if I hit forward, watch what happens. Hacked by just mumble crust, what we just did moments ago. Woo! And there you go. Software presenting is preventing from safely connecting to the site. www. Ooh, what? Oh, it's most likely a safe site, but a secure connection could not be established. This issue is caused by PortSwigger CA, which is either software on your computer network, what you can do about it. Yeah, I'm gonna hit. I'm actually gonna accept the risk and accept the risk. It's gonna try to do that. But one thing is now I want to get back. Let's come back to this in a little bit. Oh. I get a bunch of requests here. Drop. Ooh, got dropped. So if I go to cs.tufts.edu, I can also hit forward. Oh, it goes to engineering CS. Okay. I'm going to forward this request. I can just say internet. Drop everything. And so there's a lot, I think, yeah, there you go. Let me reset the database again. Now I have intercept off on Burp. Let's do this again. Intercept off. Let me just use an HTTP website now, which is, let's go to XSS stored for the request. I thought I just, oh, let me reset the database again. Sorry, I forgot. I didn't press the button. All right, here we go. That's fine. Sorry about that. Let's do intercept on again. Nope, XSS stored. Clicked on the wrong one. I don't want the DOM one. I'm going to drop that one. XSS stored. Yeah, I want to forward to that one. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, A, A. I'm going to sign the guest book. Hacked by mumble crust. And my message, instead of going to be AA, it's going to be script. Window.location equals http tufts.io. Close the script. Forward the request. Ooh, interesting. Now I got another request. Yeah, I'm going to forward that one. Yeah, I'll just forward that one. I just forward everything and I just got the Tufts.io. Sweet, 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 but we're not done yet. We're not done. There's actually a nice exercise here on Burp Suite that actually is called JavaScript. And it has everything to do with using a proxy. So I'm going to view the help on this one, and it says this JavaScript attack in this section are designed to help you learn about how JavaScript is used in the browser and how it can be manipulated. So the attacks could be carried out by just analyzing network traffic, but that isn't the point, so it's going to be much harder. Okay, whatever. All right, so press to submit the word success to win. Okay, I'm going to submit. Oh, I don't have interceptors off. Oh, what? 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 Interesting. What do you mean by that? I got an invalid token all the time. What's going on? The whole point of this exercise is to really understand not only how JavaScript works, but also how proxies work. And there's a huge hint here, it's proxies in depth. Take a look at the source code for this one. Go to View Page Source. Interesting. Wait, does it match as a view source here? Well, you better believe it. Should be. Yep, here we go. All this. So how the source actually works, how a token is generated is this. Generate the token. Var equals phrase equals document.get element by ID to phrase, whatever you type in. And then the token value is token.value equals MD5 rot13 of the phrase that you type in. That is the MD5 hash of the rot13. That means shift every letter by 13 characters of the phrase that you type in. Interesting. Is there a quick and dirty way to calculate the MD5 of the rot13 of the phrase that we type in? And the answer is yes. You want to use your web browser's developer tools for this. Go to web developer, go to toggle tools. You go to console and you do MD5 of the rot13 of the phrase is going to be success. And I get this hash, this little key right here. I'm going to copy this message, this output without the quotes. But this time I want to use the proxy. And you can see where things go wrong. Why it kept on failing. I'm going to hit intercept on. Now this time the phrase is I'm going to type success in. But here's the key. Burp intercepted the request. My phrase is success, but the token is a little bit off. The whole point of this exercise in a damn vulnerable web application is to use a proxy, intercept the token, change it to the MD5 of the rot13 of whatever the phrase is, which wasn't calculated correctly. So I changed the token to be the MD5 of the rot13 of success that we calculated using the browser's developer tools. Now I'm going to hit forward and notice what happens as now it says well done. Pretty nice. Okay, so this is how you solve the JavaScript attack issue. So using a web proxy like Burp, you can modify lots of requests, stuff that gets entered into form fields, even hidden form fields, and even cookie values. So for my security class next week, there is going to be a capture the flag game, and one of the challenges I can tell you will require the use of using a proxy, using a web proxy like Burp. to modify like values and hidden form fields, cookie values, you name it. One of the other nice outputs of the things about using Burp Suite is there's a tab called Target here. So what's nice is when we've been working with 35.196.150.0 site, but what happens is a target, and also what Burp does, it keeps track of all the folders and the structure of a website that you may need a little bit later on. So he went to a whole bunch of sites, such as like HTTP 35.190.150. So for reconnaissance purpose, you can actually see all the files on the site, all created for you. All the vulnerabilities, the folders, parses through every single HTML page, and it creates a structure of the target for you. Now, will Burp Suite work for things like Facebook and like HTTPS websites? Let's go to facebook.com. Now you see software preventing Firefox from safely connecting to the site. Facebook.com is most likely a safe site, but a secure connection could not be established. The issue is caused by Portswigger CA, which is either software on your computer. Okay, interesting. Facebook has a security strict, which means that Firefox you can add an exception to this. One of the things that you can do if your Burp's open is just go to HTTP Burp. Download the certificate authority certificate for Burp. Save that file. I'm going to save this to my desktop. Then in your web browser, go to go to setting. Oh, no. Go to Firefox preferences. Privacy and security, I believe it is. And go to certificates and view certificates. I wonder if there's anything with Portswigger in here. Oh, there's no trusted certificate. Maybe that may be the reason. Yeah, there's no trusted certificate for Portswigger, for the proxy. So that's why the proxy keeps on throwing that error message, that's why Firefox have been throwing that big warning whenever I go to any HTTPS websites. So this is what I want to do. After I download the Burp Suite certificate, the CA certificate for Burp Suite, I'm going to import, go to my desktop, cacert.der, and hit open. You've been asked to trust a new certificate authority. Do you want to trust Portswigger CA for the following purposes? Yes, trust this certificate authority to identify website. Trust this CA to identify email users. I'm going to hit OK. And now I get the Portswigger certificate as part of my certificate manager in Firefox. In short, what that means is I should now be able to go to an HTTPS website without any difficulty if I have Burp open. Proxy, forward. Oh, I'm going to drop that from Firefox. Drop it. Forward to Facebook request. Request https://facebook.com:443. Yeah, I'm going to forward that. Boom. So now, no more warnings on the web browser, no more scary yellow messages, no nothing after I actually installed this certificate authority for Burp Suite. And I'm going to forward. I'm going to close the intercept because it's getting annoying. And now you can actually see the target. You can actually start to see Burp is also creating a structure for how Facebook actually looks under the hood. Oh, I see PHP files. Can I remove this? Okay, I want to delete host. Yeah, I want to delete the selected item. Delete the selected item. Right click, delete the host. I want to delete the host. I want to delete the host, and so I can only see Facebook stuff. Delete the host. Delete the host. Okay. So now I want to actually, so of course, if you want to intercept your username and password and want to see that kind of stuff, yeah, sure. Why don't I just turn back on intercept in the proxy? And I'm going to enter in an email address, something a@b.com. Password is, so I'm going to hit the login button, and Burp should actually have intercepted the request that I actually made to Facebook. Yep, here you go. I'll forward that request. There you go. That were, nope, I don't see anything that I entered in. I can see the email I entered in was a@b.com, and then of course the password is something. Ooh, got encrypted too. Cool. Didn't know that until now. Okay. One of the nice things is, of course, you may be wondering, like, I'm going to drop this request, drop that request, drop that request. So you can see everything that's happening under the hood when, oh, I don't want to exit, no. But one of the reasons why I am using Facebook as an example in here is they have a pretty nice, a pretty generous bug bounty program. There you go. That's Facebook bug bounty program. A lot of former students have down there over there. Last updated. Yes, I am using the free version of Burp. Yep. Okay. And so, whoa, we're running way over. Yep, really nice. I have a research, response to disclosure policy, safe harbor provision, bug bounty process. You can read it. And with that said, hopefully I give you a good foundation today of web security, damn vulnerable web application, bug bounties, SQL injection, cross-site scripting. Oh, interesting. And of course, you can see in their bug bounty program, like you can actually see, SQL cross-site scripting, bypass, strictly out of scope, yada, yada, yada. So hopefully you can actually use these skills for good, And with that said, see ya. Question about cross-site scripting. Go ahead, go for it, go for it, go for it. Go for it. So that's why, of course, hello, John Little 1, you're on the air. I can answer your question live. If the alert doesn't pop up, does that mean that it's not vulnerable? That means one a couple things. Maybe the site is not vulnerable. The other thing that may not be a problem is, so look, it shows up in the HTTP response code. It means that, yeah, usually if a pop-up doesn't show up, if you don't get like an XSS bubble, it means that either A, the site is not vulnerable because, the web app actually did a pretty good job in sanitizing the input, or highly unlikely in your case that you had a typo in the payload. Yeah. Yeah, the site didn't run. What's the script that you should enter into the text field to increase? I didn't do that at all. I did not use any. What the exact script you should enter into the text field to increase the max length? I didn't need to do that. I just used Burp for that. I didn't need to modify that at all. So yeah, John, if the alert doesn't pop up, that doesn't mean it's not vulnerable. Chances are, I said chances are that, yeah, that usually means that the site is not vulnerable. Or there may be a but how do we actually do that if we don't want to use a proxy? Off the top of my head, you could, one way I can think of is just open up your web developer tools. Open up your web developer tools. I'll just show you. Can I do it here? Okay, interceptor's off. Oh, crap, hold on. I believe this is one way you can do it. Go to cross-site scripting stored. Oh man, hold on. Let me just reset the database. Yeah, you gotta develop web developer, toggle tools. You go to the inspector. Footer. Body padded. No, I want this thing. Inspect element. Ah, here it is. Yeah, and then of course you can just right here, you can just modify max length to be like 50. Yeah, and in that case you should be able to do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Yeah, I just did it. So you can use like the web developer tools on whatever browser. Every browser developer tool now is pretty consistent. That's the way I use it. If you don't want to use a proxy, then let's do that. Does this thing work? Yeah, it worked for me. All right, sounds good. I'm going off the air.